Statistics. Statistics is the branch of mathematics which deals with the collection, presentation, analysis, and interpretation of numerical data. Statistics is used in everyday life, in agriculture, botany, biotechnology, bioinformatics, chemistry, physics, economics, commerce, geography, sociology, medicine, etc. Dr. P.C. Mahalanobis, Dr. P.V. Sukhatme, Professor C.R. Rao, and Dr. V.S. Huzurbazar are some of the well-known Indian statisticians. You are familiar with the terms such as primary data, secondary data, ungrouped frequency distribution, grouped frequency distribution, inclusive and exclusive methods of classification, class width, frequency, mid-value of the class or class mark, class boundaries, etc. 1. Measure of central tendency. Central tendency means the tendency of the observations to concentrate around some values. Such a value is called as measure of central tendency. There are various measures of central tendency. They are mean, median, and mode. 1. Mean for grouped frequency distribution. 1. Direct method. Steps to calculate mean. Prepare a table containing 4 columns. In column 1, write the given class intervals. In column 2, write the corresponding class marks, that is xi. In column 3, write frequencies fi. Find sigma fi. In column 4, write the product fi xi and find the sum sigma fi xi. Calculate mean represented by x bar using the formula x bar equals to sigma fi xi upon sigma fi, where xi is the class mark of ith class interval. Fi is the frequency of ith class interval. Example: given below is the distribution of turnover in lakhs of rupees of 50 departmental stores in a year. Turnover in lakhs of rupees, number of stores, find mean turnover of a store. A table containing 4 columns is prepared. In column 1, class intervals for turnover are written, and in column 2, corresponding class marks xi's are written. In column 3, number of stores, that is, fi, of the given class intervals are written. In column 4, the product FIXI is written. Sigma Fi and sigma FIXI are calculated. Mean is calculated by using the formula x bar equals to sigma FIXI upon sigma Fi. Putting the values of sigma FIXI and sigma Fi in the formula, we get 1470 upon 50, which equals to 29.40. Thus, mean turnover of a store is Rs 29.40 lakhs. 2. Assumed mean method or shift of origin method. Steps to calculate mean are as follows. Prepare a table containing 5 columns. In column 1, write the given class intervals. In column 2, write the corresponding class marks, that is xi. In column 3, write the values of di, that is deviation, where di equals to xi minus a and a is the assumed mean. In column 4, write frequencies fi of the given class intervals. In column 5, write the product fi di. Find sum for both the columns, that is sigma fi and sigma fi di. Find the mean of di using the formula d bar equals to sigma fi di upon sigma fi. Calculate mean by using the relation x bar equals to a plus d bar. Usually, a is taken as class mark of middle class. If there are 2 middle classes, then class mark of any one of them can be taken as a or average of the middle classes. Example: following is the frequency distribution of words in an essay. Number of words, number of candidates. Find the mean number of words written. A table is prepared with the following steps. Table is drawn containing 5 columns. In column 1, class intervals are written. In column 2, corresponding class marks, that is, xi's, are written. Take A equals to 1100. In column 3, di's or deviations are written where di equals to xi minus a, that is xi minus 1100. In column 4, values of FIs are written. In column 5, values of the product of FIDI are written. Then, find the sum of frequencies, that is, sigma Fi and sigma FIDI. Calculate mean deviation as follows. D bar equals to sigma FIDI upon sigma Fi. Putting the values in the formula, we get 800 upon 100, that is 8. As mean equals to assumed mean plus mean deviation, that gives 1100 plus 8, that is 1108. Therefore, mean number of words for the given group of candidates is 1108. 3. Step deviation method or shift of origin and scale method. Steps to calculate mean. Draw a table containing 6 columns. In column 1, write the given class intervals. In column 2, write the corresponding class marks, that is xi. In column 3, write the values of deviation where di equals to xi minus a. In column 4, write the values of ui, that is step deviation, where ui equals to xi minus a upon h, that equals to di upon h, where h is the class width. In column 5, write the frequencies fi of the given class intervals. Find the sum. In column 6, write FIUI, find the sum. Find mean of UI by using the formula U bar equals to sigma FIUI upon sigma FI. Find the mean by using the relation x bar equals to A plus HU bar. Example: rainfall in millimeters recorded in 50 cities in a particular region on a particular day is given below. Rainfall in millimeters, number of cities. Find the mean rainfall on that day in a city by shift of origin and scale method. Draw a table consisting of 6 columns. In column 1, class intervals for rainfall are written, and in column 2, the corresponding class marks XIs are written. Take A, that is, assumed mean, equals to 49.5. In column 3, values of DI, that is given by XI minus A, that is equal to XI minus 49.5 are written. age, that is class width, equals to 4. In column 4, values of UI, that is step deviation, which equals to di upon age equals to di upon 4 are written. In column 5, frequencies Fi are written. In column 6, values of the product Fi Ui are written. Now, the mean of UIs is calculated by using the formula U bar equals to sigma Fi Ui upon sigma Fi. Putting the values in the formula, we get -5 upon 50 equals to -0.10. Putting the values, we get mean equals to 49.1. Therefore, mean rainfall on that day is 49.1 millimeters. Requirements of ideal measure of central tendency. It should be simple to understand. It should be easy to calculate. It should be based on all the observations. It has one and only one interpretation. It should be preferably defined by the mathematical formula so that if different persons compute the measure using the same observations, they all must get the same answer. It should be capable of further mathematical treatment. It should be least affected by the extreme observations. It should be determined graphically. Merits of mean. Mean satisfies requirements 1 to 5 of ideal measure of central tendency stated above. So, they are regarded as merits of mean. Demerits of mean. It cannot be determined graphically. It cannot be determined in case of frequency distribution with open-end classes. It is very sensitive to the changes in extreme observations. It cannot be determined by inspection. Median for grouped frequency distribution. Steps in calculation of median for grouped frequency distribution. For exclusive type class intervals, prepare a table containing 3 columns. For inclusive type class intervals, prepare a table containing 4 columns. In case of inclusive type, in next, that is second column, convert inclusive type class intervals into exclusive type, that is continuous, by subtracting average of the difference between upper limit and lower limit of any two consecutive classes from every lower limit and adding to every upper limit. Now, follow the steps as in case of exclusive type. For both inclusive type and exclusive type, write given class intervals in column 1 and their respective frequencies in column 2. Write cumulative frequency less than type in column 3. Find total frequency, that is n equals to sigma fi. Calculate n by 2. Find cumulative frequency less than type, which is just greater than or equal to n by 2. The corresponding class is median class. Calculate the value of the median by using the formula median equals to L plus n upon 2 minus Cf multiplied by h upon f. Where L equals to lower boundary of the median class, n equals to sigma fi, that is total frequency, Cf equals to cumulative frequency of the class preceding the median class, f equals to frequency of the median class, h equals to width of the median class. Example: the frequency distribution of daily wages in rupees of 130 workers is given below. Daily wages in rupees, number of workers. Find the median daily wages of workers. Now, following the steps stated before, prepare a table. As the given class intervals are not continuous, that is inclusive type, the table should have 4 columns. In second column, convert inclusive type class intervals into exclusive type, that is continuous, by subtracting 0.5 from every lower limit and adding 0.5 to every upper limit. Here, total frequency equals to sigma fi equals to n equals to 130. Therefore, n by 2 equals to 65. Cumulative frequency of less than type, which is just greater than 65, is 95. Therefore, corresponding class 94.5 to 99.5 is the median class. According to formula, median equals to L plus N by 2 minus CF multiplied by H upon F, where L equals to lower boundary of the median class, that is 94.5, N equals to total frequency, that is sigma Fi, CF equals to cumulative frequency less than type of the class preceding the median class, that is 55, H equals to width of the median class, that is 5, F equals to frequency of the median class, that is 40. Here, L equals to 94.5, N equals to 130, thus N by 2 equals to 65, CF equals to 55, H equals to 5, F equals to 40. Putting the values in the formula, we get median equals to 94.5 plus 65 minus 55 multiplied by 5 upon 40. Equals to 94.5 plus 50 upon 40 equals to 94.5 plus 1.25 equals to 95.75. Therefore, median daily wages of workers is Rs 95.75. Merits and demerits of median. Merits. It is simple to understand. It is easy to calculate. In some cases, it can be determined by observation. It can be determined graphically. It is not affected by extreme values. Demerits. It is not based on all the observations. Its calculation requires arrangement of observations in ascending or descending order of magnitude. It is not capable of further mathematical treatment. Mode for grouped frequency distribution. Observations having maximum frequency is mode in case of grouped frequency distribution. Find the maximum frequency, denote it by Fm. Determine the class corresponding to Fm. This class is called as modal class. Calculate the value of mode by using formula mode equals to L plus Fm minus F1 upon 2Fm minus F1 minus F2 into H, where L is the lower limit of modal class, Fm is the maximum frequency, F1 is the frequency of pre-modal class, F2 is the frequency of post-modal class, and H is the width of modal class. Example: the weight of coffee in grams in 70 packets is given below. Weight in grams, number of packets. Determine the modal weight of coffee in a packet. Class 201 to 202 has the maximum frequency 26. Therefore, 201 to 202 is the modal class. Here, L equals to 201, Fm equals to 26, F1 equals to 12, F2 equals to 20 and H equals to 1. As mode is given by the formula L plus Fm minus F1 upon 2Fm minus F1 minus F2 multiplied by H. Putting the values, we get 201 plus 26 minus 12 upon 2 multiplied by 26 minus 12 minus 20 multiplied by 1. That gives 201 plus 14 upon 52 minus 32 equals to 201 plus 14 upon 20 equals to 201 plus 0.70 equals to 201.70 grams. Thus, modal weight of coffee in a packet is 201.70 grams. Merits and demerits of mode. Merits. It is simple to understand. It is easy to calculate. It is not affected by extreme values. In case of ungrouped data, it can be determined just by inspection. It can be determined graphically. Demerits. It is not based on all the observations. It is not capable of further mathematical treatment. It is not unique. It may not exist. It cannot be determined in case of grouped frequency distribution if modal class is at the end of the distribution. Interrelation between measures of central tendency. There exists an empirical relationship among mean, median, and mode. This relationship was stated by Professor Carl Pearson on the basis of his vast experience. The relationship is mean minus mode equals to thrice of the difference between mean and median. It cannot be proved theoretically but is observed to be valid for a number of data sets after actual calculations. Example: for a certain frequency distribution, values of mean and median are 62.6 and 62.5 respectively. Find the value of mode. Solution: mean equals to 62.6 and median equals to 62.5. Mean minus mode equals to thrice of mean minus median. Putting the values of mean and median in the formula, we get 62.6 minus mode equals to 3 multiplied by 62.6 minus 62.5, or 62.6 minus mode equals to 3 multiplied by 0.1, or 62.6 minus mode equals to 0.3. Therefore, mode equals to 62.6 minus 0.3 equals to 62.3. Therefore, mode value for the given frequency distribution is 62.3.
Graphical representation of statistical data. If a data is represented graphically or diagrammatically, it becomes simple to understand and interpret. The specific graphs associated with frequency distribution are as follows. 1. Histogram. 2. Frequency polygon. 3. Frequency curve. Histogram. It is a series of adjacent rectangles erected on x-axis with base as class intervals. The height of rectangle is proportional to the corresponding class frequency. Procedure to draw a histogram. 1. Make class intervals continuous, that is, extended class intervals if they are not continuous. 2. Take extended class intervals on the x-axis. 3. Take frequencies on the y-axis. 4. Draw rectangles on the x-axis with base as extended class intervals. 5. Take height of the rectangles proportional to the corresponding frequencies. Example: following is the frequency distribution of waiting time at ATM center. Draw a histogram to represent the data. Waiting time in seconds. Number of customers. In the given example, the class intervals are already continuous, that is, extended. According to the data, set the scale. X-axis 2 centimeters equals to 30 seconds. Y-axis 1 centimeter equals to 10 customers. Take extended class intervals, that is, waiting time in seconds in this case on x-axis. Take frequencies, that is, number of customers in this case on y-axis. Draw rectangles on the x-axis with base as extended class intervals and height proportional to corresponding frequencies. This is the required histogram representing the given data. Example: draw a histogram for the following frequency distribution. Weight of boys, kilograms. Number of boys. The classes in the given table are to be made continuous. The gap between two consecutive classes can be bridged by extending the classes equally at both the ends, that is, subtracting 0.5 from every lower limit and adding 0.5 to every upper limit. Thus, the new table is extended classes, frequencies. According to the data, set the scale. Note: the crink mark given on x-axis near the origin represents any fold in the graph paper. X-axis 2 centimeters equals to 5 kilograms. Y-axis 1 centimeter equals to 2 boys. Take extended class intervals, that is, weight in kilograms in this case on x-axis. Take frequencies, that is, number of boys in this case on y-axis. Draw rectangles on the x-axis with base of extended class intervals and height proportional to corresponding frequencies. This is the required histogram for the given data. Uses of histogram. 1. Histogram is used to find mode. It is also used to construct frequency polygon and frequency curve. 2. Histogram gives an idea about average, where it is located. 3. It tells us about the spread of the data. 4. It gives an idea about the symmetry of frequency distribution. 5. If two different data sets are mixed, the histogram of such a mixture will have two peaks. Frequency polygon. Histogram gives a rough idea about the nature of frequency distribution. The border of histogram represents the frequency distribution. The border is zigzag, so we need to make it more smooth. Using frequency polygon, it is possible to do so. The following figure will demonstrate how to make the border smooth. To draw frequency polygon curve, there are two methods. 1. Using histogram. 2. Without using histogram. Flow chart for the procedure of drawing a frequency polygon. Prepare frequency distribution table with class marks xi. Draw x-axis, y-axis. Choose proper scale. Take class marks on x-axis. Take frequencies fi on y-axis. Plot the points xi, fi. Plot two additional points with two additional classes, one preceding the first class with frequency 0 and the other succeeding the last class with frequency 0. If we join all the successive points, including the two additional extreme points, by straight line, eventually the closed figure so obtained is frequency polygon. If we join all the successive points, including the two additional extreme points, by smooth freehand curves, eventually The closed figure so obtained is frequency curve. Frequency polygon can be drawn using histogram. 1. Draw a histogram. 2. Mark the midpoint of the upper side of each rectangle of the histogram. 3. Take one additional rectangle of height 0 preceding the first rectangle and one more additional rectangle of height 0 succeeding the last rectangle. 4. Mark the midpoints of these two additional rectangles. Such marks will be on x-axis, since the rectangle has height, that is, frequency 0. 5. Join the successive points by straight line and get a closed figure. This is a frequency polygon. Area bounded by frequency polygon equals to area bounded by histogram. Example: the following is a frequency distribution of maximum temperature recorded weekly in a certain year at a certain observatory. Draw frequency polygon and frequency curve for the given data. Maximum temperature in degrees Celsius. Number of weeks. The class marks for the given data along with two additional ones, that is, preceding and succeeding ones, are as follows. Class marks. Number of weeks. Scale. X-axis. 1 centimeter equals to 5 degrees Celsius. Y-axis. 1 centimeter equals to 2 weeks. Take class marks on the x-axis and frequencies, that is, number of weeks on y-axis. Plot the points xi, fi. Join all the successive points, including the two additional extreme points, by straight lines. The closed figure so obtained is the frequency polygon for the given data. If all the successive points, including the two additional extreme points, are joined by smooth freehand curves, the closed figure so obtained is called a frequency curve. In this chapter, we will study some methods of diagrammatic representation of data and also the graphical methods of representing data. Pictorial representation of statistical data. Pie diagram. In a pie diagram, the values of items or components are represented by sectors of circle formed using a convenient radius. The sectors resemble the slices of a pie, a bakery product. Hence, the diagram is called pie diagram. The terms used in a pie diagram are sector and central angle. In the given figure, O is the center of the circle. Angle AOB is the central angle. The shaded region OAXB is the sector in the circle. Construction of pie diagram. The total of all values of items or that of components corresponds to 360 degrees. So, first, find the central angle for each item or component using the following formula. Central angle represented by theta is given by value of the item or component upon total value of all the items or components multiplied by 360 degrees. Next step involves drawing a circle of convenient radius and then dividing it into sectors as per the number of components. Example: the marks obtained by a student in an examination are given below. The total marks obtained in various subjects are as follows. Subject, marks, represent the data using pie diagram. First, we compute the central angle for each subject as shown in the table. The measure of central angle for Marathi as calculated is 85 degrees. The measure of central angle for English as calculated is 85 degrees. The measure of central angle for science is 90 degrees as per calculation. And the measure of central angle for mathematics as per calculation is 100 degrees. Now, we draw a circle of a convenient radius. We then draw sectors with the calculated measures of central angles using a protractor. This is the required pie diagram for the given data. Reading the pie diagram. The data already represented in a pie diagram can be retrieved when needed. Comparison of items from two pie diagrams can be done. Example: the pie diagram given represents the amount spent on different sports by a school administration in a year. If the money spent on football is 9,000 rupees, answer the following questions. 1. What is the total amount spent on sports? 2. What is the amount spent on hockey? 3. What is the amount spent on cricket? 4. How much more amount is spent on tennis than on basketball? 1. Let X be the total amount spent on sports. Therefore, the total amount X rupees corresponds to central angle, that is 360 degrees. Since we know the expenditure on football, we proceed as follows. Central angle for football equals to expenditure on football upon total expenditure multiplied by 360 degrees. From the given figure, the central angle for football is 45 degrees. Therefore, 45 degrees equals to 9,000 upon x multiplied by 360 degrees. Therefore, the total expenditure on sports is 72,000 rupees. 2. The central angle for expenditure on hockey is 100 degrees as given in the figure. Therefore, 100 degrees equals to expenditure on hockey upon total expenditure multiplied by 360 degrees. Putting the value of total expenditure as calculated in the formula, we get 100 degrees equals to expenditure on hockey upon 72,000 multiplied by 360 degrees. This equals to 20,000 rupees. Therefore, amount spent on hockey is 20,000 rupees. 3. The central angle for expenditure on cricket is given by expenditure on cricket upon total expenditure multiplied by 360 degrees. Putting the value of central angle for expenditure on cricket as given in figure and total expenditure, we get 160 degrees equals to expenditure on cricket upon 72,000 multiplied by 360 degrees. Therefore, amount spent on cricket is 32,000 rupees. 4. The difference in central angle due to expenditure on basketball and tennis according to the values given in the figure is 35 degrees minus 20 degrees equals to 15 degrees. Therefore, difference in angle equals to difference in expenditure upon total expenditure multiplied by 360 degrees. Putting the values in the formula, we get 15 degrees equals to difference in expenditure upon 72,000 multiplied by 360 degrees. Thus, difference in expenditure is 3,000 rupees.